Wishing you all a very, very pleasant morning. Materials fascinate me. Materials are the most fascinating subject of engineering. When I was a student like you, later part of 6 years, I had a subject called engineering materials. We used to study, or our faculty used to tell us, what are the materials available in nature, what are their properties, and how best we can use them for engineering purposes. I repeat, we had a subject called engineering materials. The subject of study was the materials available in nature, how to use it for engineering purposes. Last 40 years, we have migrated from engineering materials to engineered materials. I request you to make, please note the difference between engineering materials to engineered materials. Now we are engineering materials to our requirement. We don't select a material available in nature and use it as is available. We will have engineered that material. We will have altered the properties of the material and then use it for the specific purpose. We will have engineered materials for different purposes. I request you to know the difference between engineering materials to engineered materials. Composite materials are engineered materials. We engineer their properties. We make them to suit our requirements, properties, and the working environment. We come a long way. As Professor Sitaram said, way back in the early 70s when we were colleagues at the Indian Institute of Science doing research together, independently, but under one roof, we had a colleague who is presently the director of Indian Institute of Technology at Ropar, Punjab. His name is Professor Surappa. He used to dabble in graphite aluminum matrix. That was the beginning of matrix material or composite materials in this country. Pioneered at Indian Institute of Science by a professor called Rohat Gill, who was a graduate from MIT, Massachusetts Institute of Technology, USA. Those were the beginning of composite materials in this country. We were witness to that. We were not a part of it. We were witness to that. If you look at nature, all the materials we look at nature, if you look at them, they are all composites. In nature, there is nothing like a pure substance available and being used by nature for its purposes. It's all composites. I used to look at banana leaf when I was a kid, when I was a student. When I didn't know what banana leaf is, what is it made of, I always land up in a festival, when the food is served on a banana leaf. I used to always land up with a banana leaf torrent. Never had a good banana leaf to eat on. Always torrent, something leaks out of it when I eat. But I look at the damage done to the banana leaf. It was always vertical. The crack migrated from the tip of the banana leaf towards the root, towards the let's say stem. Always wondered why that happens to banana leaf. Why doesn't care the other way around? Why it always starts from the edge and the crack propagates towards the stem, always vertically. I have never seen a banana leaf torn other way around, parallel to the stem. Please do that today. I want you to take a banana leaf and then try to tear it parallel to the stem. You will not be able to succeed at all. Because banana leaf is a composite material. Banana leaf is fiber reinforced composite. This property, when you really look at the study, will be excellent across this fiber, will be very, very poor along the fiber. Space shuttles. Professor Sitaram said that composites have a very significant role to play in aerospace industry transport. Their power to weight ratio is a very significant factor. Weight has to be lower, power has to be higher in order to apply the power effectively. Space shuttles, if you look at the space shuttles, probably 50-60% of it is composite material. I am sure the fighter planes that they are manufacturing today are probably all composite fibers material, all composite. But for engine parts, which has to withstand high temperature, otherwise the structural parts would be composite materials. Space shuttle with a heat shield. I saw a synopsis yesterday in the proceeding. One of our own college students is presenting a paper on carbon-carbon composites for heat shields in a space shuttle, re-entry vehicles. It could be carbon-carbon composites or zircon-zircon composites. Very significant role. Let's not look at the use of composite material only for exotic use like space shuttle, spacecrafts, aircraft. I was told that composites, fiber reinforced composites are being used for water supply lines. Look at our own country, we don't have a water, piped water in probably 70% of our villages. We enjoy piped water only in Bangalore. When you lay pipes, I was told that some of them are plastic pipes. If you lay them plastic pipes, over a span of 5 years to 10 years time, they become brittle and they break. You need to relay them all over again and again, which could be expensive. I was told that fiber reinforced plastic pipes which are being developed will last for about 20 years without becoming brittle and being replaced. So application of composites has very relevance to our society needs today. We are not looking at space, we are not looking at Chandrayans. They are relevant to us in the present day context of our needs of the society. Composites are fascinating. When I have a very disturbing day in the college, there are quite a few of them. I get disturbed mentally when I lie down in the bed in the nights. I switch over to materials. I start thinking of materials. How fascinating the materials are. You start looking a little deeper into the material science, it's absolutely fascinating. It relieves you of your stress. You get distressed by the thinking, what could be the prospect, what are the needs? I keep telling my fourth year A semester students about the inadequacy of materials available as on today. As we only had better material for the manufacture of engine cylinder, IC engine cylinder, which is presently clay graphite iron, to something else which has the same wear properties and the same strength, and which has much better strength, so it's much better than clay graphite iron that is presently being used. You could have engines with an efficiency more than, let's say, 50%. The efficiency of IC engines, I keep telling my students in my class that efficiency of automobiles we run today is anywhere between 20 to 25%. 75% of the fuel we inject energy is wasted. So you are the people who will make this happen. Composites could only be the way where we improve our materials and then hence the utility, energy, utilization, effectiveness. Professor Sitaram has played a significant role in this. As the head of CPRI, he has understood the importance of composite materials and has individually made a very significant contribution to the field of science of composites. We must congratulate him on that. And I request you all of you to realize the importance of the role played by the composites in the today's needs of this, our society. Not talking about American society, or not about European. It's relevant to our society needs as of today. With this, I only hope that the deliberations which take place in the next 2 days will enthuse you. Do not make you an expert in composite materials, very difficult and very understandably. It's not the purpose of this seminar either. If it only enthuses you to take interest in the composite materials, our day would be done. Thanking you, wishing you all a good day. Thank you.
Silence, please. Now I request the